You slip on a wet floor. Your foot twists beneath you. A sharp crack echoes through your leg. Suddenly, standing feels impossible. Every movement sends pain racing through your body. Today, you would probably call an ambulance. Within hours, an X-ray would reveal the damage. A cast would hold the bone in place while doctors monitored your recovery. But imagine the same injury 40,000 years ago. No hospitals, no painkillers, no plaster casts, no metal plates, no antibiotics. Just you and a broken bone in the middle of a world filled with predators, freezing nights, and long migration. At first glance, it seems obvious what happened. You died. For decades, many researchers believed exactly that. A serious fracture in the Ice Age appeared to be little more than a death sentence. Hunter-gatherers depended on movement. If you couldn't walk, you couldn't hunt. If you couldn't hunt, you couldn't eat. And if your group kept moving, as most did, you would simply be left behind. It sounds brutally logical, except the evidence tells a completely different story. Across Europe, Asia, and the Middle East, archaeologists have uncovered skeletons tens of thousands of years old that carry unmistakable signs of devastating injury. Broken legs, crushed arms, damaged hips, multiple fractures. And the remarkable part isn't that these injuries happen, it's that the bones heal. Some individuals survive not for days or weeks, but for years after suffering injuries that would leave many modern people bedridden without surgery. That single discovery changes one of the oldest assumptions about prehistoric life. It suggests ancient humans weren't surviving because they were stronger than us. They survived because they rarely survived alone. This isn't speculation. It begins in a cave in northern Iraq. In 1957, American archaeologist Ralph Seletsky began excavating a site called Shanidar Cave, tucked into the Zagros Mountain. Hidden beneath layers of sediment, his team uncovered the remains of several Neanderthals dating to roughly 45,000 to 50,000 years ago. One skeleton immediately stood out. Today, researchers call him Shanidar 1. His body tells an extraordinary story. His right arm had suffered a catastrophic injury, likely leaving it with little or no function. Parts of the lower arm were missing. His shoulder showed severe degeneration. One foot carried evidence of major trauma. His skull bore signs of at least one crushing blow. Studies published decades later also suggested significant hearing loss. Taken together, these injuries would have made daily survival extraordinarily difficult. Imagine trying to hunt large animals while using only one functional arm. Imagine climbing rocky hillsides with a damaged leg. Imagine detecting wolves or rival groups without full hearing. Even gathering firewood would become dangerous. Yet Shanidar 1 didn't die when these injuries occurred. His bones reveal extensive healing. Researchers estimate he lived for many years afterward, possibly into his 40s, an advanced age for the late Pleistocene. That raises a difficult question. A single person with those disabilities could not easily stalk prey across kilometers of rugged terrain. They could not carry heavy carcasses back to camp. They would struggle to defend themselves during attacks. So someone else must have helped. Food had to be shared. Shelter had to be maintained. Protection had to be provided. For years, this transformed Shanidar 1 into one of the strongest pieces of evidence that compassion and cooperation were already deeply rooted in human evolution long before farming, cities, or written history. But Shanidar wasn't the only surprise. Thousands of kilometers away, another skeleton would push the story even further back in time. In the mountains of northern Spain lies Cima de los Huesos, or Pit of Bones. The site contains the remains of at least 28 ancient humans, dating to around 430,000 years ago. They belonged to a population often considered ancestors of Neanderthals. Among them was an individual with severe skeletal abnormalities that would have limited movement throughout life. Other remains showed healed fractures that required months to recover. By itself, one healed injury could be dismissed as luck, but dozens of examples appearing across continents and separated by hundreds of thousands of years point toward something much larger. Care wasn't an exception. It may have been part of survival itself. Modern hunter-gatherers offer a clue why. Anthropologist Kim Hill, who spent decades studying the Ache people of Paraguay, documented an uncomfortable reality about human life. Hunting is unpredictable. Even skilled hunters often return empty-handed. On many days, one person succeeds while another fails. If everyone kept only what they personally caught, entire families would regularly starve. Instead, successful hunters share, not because they expect immediate repayment, but because someday they will be the unlucky one. Over time, that system protects everyone. A broken leg simply makes the need for cooperation even more obvious. You don't help someone because they are useful today. You help because next season it might be your turn. But here's where it gets stranger. Surviving a broken bone wasn't just about kindness. It forced ancient humans to solve a problem that every modern hospital still faces today. How do you keep a shattered skeleton from breaking itself all over again? Long before anyone understood biology, ancient humans understood one thing. A broken limb that keeps moving does not heal. You don't need an X-ray to discover that. You only need to watch the pain return every time the bone shifts. Somewhere in prehistory, people began solving that problem using the simplest materials around them. Straight branches, flexible vines, animal hide, plant fibers. None of these survive well in the archaeological record. Wood rots, leather decays, rope disappears after thousands of years. But bones preserve something just as important: the healing itself. Orthopedic researchers can often tell whether a fracture remains stable during recovery. Bones that heal badly show twisted alignment, shortened limbs, or joints permanently displaced. Others fuse in surprisingly straight positions, suggesting the broken pieces stayed relatively still while new bone formed. That stability rarely happens by accident. In 2015, researchers studying prehistoric fractures from Europe noted that many healed in ways remarkably similar to untreated but immobilized fractures seen before modern surgery. The body had done the repair. The challenge was simply giving it enough time. Time was expensive. A broken tibia, the large bone in your lower leg, often needs 3 to 6 months to heal even today. During that period, a hunter could lose an entire season of mobility. That meant everyone else had to compensate. Someone gathered extra firewood. Someone carried water. Someone processed animal hides. Someone watched for predators while the injured person rested. A broken bone didn't become one person's problem. It became the group's problem. Evidence from prehistoric camps suggests these groups were already organized in ways that made this possible. At sites such as Dolní Věstonice in the present-day Czech Republic, dating to about 30,000 years ago, archaeologists uncovered large communal living areas, multiple hearths, and evidence that dozens of people occupied the same settlement. Life wasn't built around isolated families. It revolved around small communities. That mattered because recovery requires something hunters rarely had in abundance: stillness. But there was another challenge that modern medicine solves almost automatically: pain. A fractured femur is considered one of the most painful injuries the human body can experience. The muscles surrounding the bone contract violently. Even slight movement becomes unbearable. Without pharmacies, how could ancient humans endure weeks or months of recovery? The answer may have been growing beneath their feet. In northern Spain, at El Sidrón Cave, scientists analyzed hardened dental plaque from Neanderthal teeth dating to roughly 49,000 years ago. Inside that fossilized plaque, researchers found microscopic traces of yarrow and chamomile. These plants are unusually bitter. They offer little nutritional value, but both have long histories in traditional medicine. Chamomile contains compounds with anti-inflammatory properties. Yarrow has been used for centuries to help reduce pain and support wound care. No one can say with certainty why those Neanderthals consumed them, but their presence suggests prehistoric humans recognized that some plants did more than satisfy hunger. They could change how the body felt. That knowledge likely accumulated over thousands of generations. Trial, error, observation, memory. If one plant eased pain after an injury, people remembered. If another caused sickness, they avoided it. No textbooks existed. The landscape became the library, and every generation added another page. Except pain wasn't the greatest threat. Infection was. Today, antibiotics make many broken bones routine injuries. Before their discovery by Alexander Fleming in 1928, even relatively small wounds could become fatal once bacteria entered damaged tissue. For prehistoric humans, the danger was even greater. Open fractures exposed bone directly to dirt, animal waste, and countless microorganisms. One infected wound could spread through the bloodstream within days. Yet many ancient skeletons show no evidence of overwhelming infection after severe injuries. Why? Part of the answer lies in the type of fractures people suffered. Many healed injuries were closed fractures where the skin remained intact. Those breaks are far less vulnerable to bacterial invasion than open ones. But environment also matters. Small hunter-gatherer groups rarely lived for long in the same location. Instead of accumulating waste around permanent settlements, they moved repeatedly across the landscape. That constant movement may have reduced exposure to many disease-causing organisms that flourish in dense populations. Ironically, life became much more dangerous thousands of years later. When agriculture spread after about 10,000 BCE, humans began living close together with domesticated animals. Villages grew, waste accumulated, new diseases evolved, population density increased dramatically. Some researchers argue that while farming produced more food, it also introduced an entirely new world of infectious disease. In certain ways, a hunter with a broken leg living among 20 people may have faced fewer disease risks than a farmer living among 200. But surviving the injury was only half the battle. Eventually, every survivor had to do something that seemed impossible: stand up again. And that reveals one of the most astonishing abilities of the human body. The first step was probably the hardest, not because the bone was still broken, but because the brain remembered the pain. Anyone who has recovered from a serious fracture knows the feeling. Even after doctors say the bone has healed, your body hesitates. You shift your weight carefully. You avoid sudden movements. Every step feels like a question. Ancient humans experienced the same hesitation, except they had no doctor doctor to reassure them. Only experience. Fortunately, the human skeleton is remarkably good at repairing itself. Within hours of a fracture, blood begins clotting around the break. Within days, specialized cells remove damaged tissue. Over the next several weeks, a soft callus forms, acting like a biological bridge. Gradually, minerals harden that bridge into new bone. Over months, and sometimes years, the body reshapes the repaired area until it can withstand daily stress again. This process is called bone remodeling. It has existed for hundreds of millions of years, long before humans ever appeared. You inherited it from countless ancestors who survived long enough to pass it on. Every healed fracture found in an Ice Age skeleton is evidence that this ancient repair system was already working with astonishing efficiency. But biology alone wasn't enough. Muscles weaken quickly after weeks without use. Balance disappears. Joints stiffen. The first walks after recovery were probably short and painful. An injured hunter may have started by carrying small bundles of firewood instead of heavy animal carcasses. A parent recovering from a broken ankle may have stayed close to camp before joining longer journeys. Healing wasn't a single moment. It was a gradual return to the group. And that return mattered because prehistoric life demanded movement. Research on modern hunter-gatherer societies, including the Hadza of Tanzania, shows that adults commonly walk 6 to 10 miles, about 10 to 16 kilometers, in a single day while gathering food, checking traps, or visiting neighboring camps. Some days were even longer. Your ancestors evolved in motion. A broken leg temporarily removed someone from that rhythm. Recovery meant earning it back. The archaeological record suggests many did. At Dolny Vestinus, archaeologists discovered individuals with healed fractures who continued living within their communities long after their injuries. At Shanidar Cave, the damaged Neanderthal known as Shanidar I survived into middle age despite disabilities that would have affected nearly every aspect of daily life. These weren't isolated miracles. From France to Israel, from Spain to Siberia, healed bones appear again and again in prehistoric remains. Different climates, different populations, different time periods, the same pattern. Humans cared for one another. That realization has changed how many anthropologists think about intelligence. For a long time, archaeologists searched for the single feature that made humans unique. Was it toolmaking, fire, language, art? In 2020, the renowned paleoanthropologist Donald Johanson, best known for discovering the famous fossil Lucy in Ethiopia in 1974, reflected on a different possibility. The traits that allowed humans to dominate the planet may not have been physical strength alone. They may have been cooperation, communication, and long-term care. Those abilities leave fewer fossils than stone tools, but they leave unmistakable consequences. A healed femur, a repaired arm, an elderly individual who could not have survived without years of assistance. In 2012, evolutionary anthropologist Brian Hare proposed something similar in his work on human evolution. He argued that our greatest advantage was not aggression, but an unusual ability to cooperate with unrelated individuals. That idea fits surprisingly well with the archaeological evidence. A broken bone creates a simple test. If everyone acts only for themselves, the injured die. If the group shares food, protects the vulnerable, and waits for recovery, everyone becomes more resilient over time. Natural selection doesn't reward only the strongest individual. Sometimes it rewards the strongest community. And perhaps that's the most unexpected part of this story. When you picture prehistoric life, it's easy to imagine endless violence, constant competition, every person struggling alone against nature. The fossils reveal something quieter. Again and again, they show people who should not have survived, but did. Not because the Ice Age was gentle, not because broken bones healed faster, not because ancient humans felt less pain. They survived because someone stayed, someone carried the extra weight, someone shared the food, someone waited while another person healed. The next time you see the pale line of an old fracture on an X-ray, or feel the ache of a bone that broke years ago, you're feeling more than an old injury. You're carrying evidence of a survival strategy older than civilization itself. Your bones know how to heal, but the reason you're here today may have less to do with your bone, and more to do with the people who refused to leave the injured behind.